Alright, so in this diagram we can see that we have one right angled triangle here, A, B, E, and we can label some of the sides here. Usually we label sides based on the opposite angle, so this side length we'd call lowercase a, and the side opposite to E we would call lowercase e. And we could also insert in another line so that we have two more right angled triangles. Can you see where? If you spotted this, well done. It's between B and D. So now we have two more right angled triangles. Let's do it in a different colour. We see we have B, C, D, and also we have A, B, D. This blue one here. So we're going to use Pythagoras' rule, but first we need to have some side lengths inserted in here. So if this side length is A, then that equal side length there, we're told, should also be A. Now for this side length here, we've already used the vertex E, so let's use this vertex C to describe this hypotenuse here. So now let's write down Pythagoras' rule for all of the triangles. It doesn't really matter the order, but let's start with, well, let's label them. This is a good idea. If you don't have a coloured pencil, you can always label the triangles. 1, 2, 3. So let's start with triangle 1. So triangle 1 here, we have the hypotenuse is C, so C squared is equal to A squared plus X squared. In the third triangle, let's say, we can use C squared as well. And by using the same hypotenuse, we can equate the terms here. So the other sides are E squared, and if we join the whole length here, we see that that's 5 squared. So that means that if two things are equal to the same thing, then they must be equal to each other. So we can write A squared plus X squared. It must be equal to E squared plus 5 squared. So the important thing in all that was to spot that this line here, C, was common to both the blue and the red triangle, so we could equate them. And now let's use the last bit of information in triangle 2. The hypotenuse is opposite to the right angle, so that's side length A, so we can see A squared, and the other two lengths are E and 2, the shorter sides. So now we can substitute in E squared plus 2 where we had A squared in our formula here. So now this will become E squared instead of A squared, E squared plus, let's say, 4 for 2 squared, and then the rest of the formula will stay exactly the same, except let's simplify 5 squared to 25. And so we should see now we can subtract E squared from both sides, and we only have one variable now, so we'll subtract 4, and we'll have 21. Take the square root, and x will be the square root of 21, not forgetting that because x is a length, we are given units in the question, so we say x is the square root of 21 centimetres.